So we're about to look at the January 2024 exam. Are you ready? Well, first, before we get started, let's have a peek at the scoring conversion chart. Okay, so again, here is the 65%. You can see again in January, same as in August, you needed 51. So typically 50 is the mark, but could be a little higher. Rarely a little lower, but about 50, 51 typically. And then if we look, in order to get an 85, you needed 75 points. Again, that is an increase of more than 20 points. Why? A couple 68s, a couple 66s, a couple 73s, and so on. Okay. Again, also notice this. 264s, 263s, 261s. So to get from 60 to 65, way more than 5 points. Okay, so again, on the multiple choice, we're aiming in our mind 40 or higher correct. 35 is acceptable toward getting you to that passing grade, but we're aiming for 40 or higher. All right, January 2024 exam time. We're going to start with Part A. Part A are the easiest multiple choice questions. Don't involve a lot of steps. Should be fairly straightforward. Okay. Which particles surround the nucleus of a neon atom? So if we're looking at an atom, what do we have in the center? We have a nucleus, and then we have electrons in orbitals, right, in energy levels surrounding the nucleus. So which particles are found outside or surrounding the nucleus? Yeah, that's electrons. Which conclusion was proposed as a result of an experiment during which some alpha particles were deflected while passing through a thin sheet of gold foil? So the gold foil experiment, what did that do? Well, since most of the alpha particles literally went through, okay, it determined that the atom was mostly empty space, right? But this is asking about why were some deflected? Well, some were deflected because what did they bump into? They bumped into a small but dense, positively charged nucleus. Number 3, the mass of each proton and each neutron is approximately equal to. Well, for this one, there is a reference table that I can use for help, and that is Table O. Okay, so it was asking me about proton and neutron, right? So if we look at Table O, proton and neutron, what do they have the same? They have the same, this top number, right? What is the top number? Mass. What is the bottom number? Charge. If it is a 1 or greater, it's the number of protons. So the top number is mass. So what is their mass? 1U. Number 4, which statement describes the relationship between 2 electrons in an atom of magnesium in the ground state? Okay, so I can see that it's talking about first shell, second shell, first shell, second shell, and I can see it's talking about same or greater. I see third shell mentioned. All right, so let's just briefly go over that. Here we have a nucleus, and then we have energy levels or shells with electrons in them. So this would be first energy level, second energy level, third energy level, or first shell, second shell, third shell. When do I get more energy? The further away from the nucleus I go. So does the electron in the first shell have the same energy as the second shell? No, because the second shell is further away. Does an electron in the first shell have a greater energy than the second shell? No, because it's the second shell that's further away. An electron in the second shell has the same energy as electron in the third shell? No, because the third shell is further away. Well, this one better be right. An electron in the third shell has a greater energy than the second shell. Yep, you bet, sure does. All right, number 5. As an atom in the ground state changes to an atom in an excited state, the atom what? Well, here's what's important to remember for these two choices that I'm going to cross out right now. The atom doesn't change in the number of particles it has. Also, mass number are the particles in the nucleus, and those are never lost or gained in terms of going from ground state to excited state, so that's not changing. In fact, the number of electrons doesn't change. But in excited state, so here we have our atom again, nucleus, energy level, energy level, energy level. That electron, right, will move up to a higher energy level to get to an excited state. So that means it must be absorbing energy. Number 6, which statement describes a chemical property of copper? So a chemical property is something where I have to try and force it into a chemical reaction in order to identify it. So copper has a red-orange color? Nope. Copper can be flattened into sheets? Nope, that's malleable. Copper reacts, oh, look at that keyword, react, 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 react. That's a chemical property, okay? And copper conducting electrical current is just another physical property. Number 7, at STP, two forms of solid carbon, diamond and graphite, have different properties because. Why do they have different properties? Why does anything ever have different properties? Because they have a different structure. Different properties result from different structures. Period. End of story. Always the answer. Okay? Number 8, which element in period 2 has the highest first ionization energy? Okay, so now I need a reference table, right? So let's go to our reference table. And it says which element in period 2. Okay, so here's period 2. Let's look up the first 3. So Li, Be, and B. So I still need the reference table. So I'm going to go Li. All right, so here we go. We start here. Here's where period 2 starts. And where does period 2 end? It starts with lithium and ends with neon. So from lithium to neon. So this is all period 2. Okay, so if I go back to the question, has the highest first ionization energy. So first ionization energy right here is this column. So I'm looking at these numbers, right? Which one is the highest? Well, it's obviously this one. And there it is, neon. Number 9, which phrase describes a specific compound? Okay, so remember matter is either a pure substance, right, or a mixture. If it's a pure substance, it's either an element or a compound. If it's a mixture, it's either heterogeneous or homogeneous. So what is a compound? Well, a compound does not contain only one element. A compound contains 2 or more elements, right? Can a compound be separated physically? Nope, that's a mixture. All right, is it composed of elements chemically combined in a definite ratio, or is it composed of elements mixed in proportions that can vary? Chemically combined in a definite ratio. This, number 4, is the definition for a mixture. They are mixed in proportions that can vary. You can have it saltier or sweeter, or you can have more of something. In a mixture, the proportions can change. In a compound, there's always a definite ratio. What does that mean? That means H2O, which is water, is always 2 hydrogens and 1 oxygen 100% of the time. Okay? All right, we're on to question 10. Which type of chemical formula shows the arrangement of the atoms in a molecule? So, for example, which one would show that water, right, looks like this, right? Or that ethane looks like this. So what kind of formula shows that? The arrangements? Yeah. It's structural formula. That's the one that shows the arrangement. Okay. Empirical is the reduced to lowest terms. Molecular shows you exactly which atoms are in the molecule, but not how they're connected, how they're arranged. Okay. Number 11, a 2.50 liter sample of SO2 gas at STP and a 2.5 liter sample of CO2 gas at STP can be differentiated by comparing their. Okay, well, let's see. Liters measures what? Volume. Well, they have the same volume. STP, right? Standard temperature. So that's 273 Kelvin or 0 degrees Celsius. What is phases? Phases mean states of matter. So look at them. They're the same. So what can they be differentiated by? Their masses, because they're made up of different elements and different amounts of those elements. Number 12, which terms identify the two major categories of compounds? Well, it is ionic and covalent, but I don't see that as an option. So there is another term that I can use for covalent, and that is molecular. So ionic and molecular, or ionic and covalent. So the one that we see here is ionic and molecular. Number 13, which molecule of an atom contains a multiple covalent bond? Okay, this will be helpful if you don't remember it off the top of your head to look at the reference table. Okay, so when I look at the reference table, I'm going to go to the periodic table and I'm going to look for these elements and find their valence electrons. Okay, so bromine has 7 valence electrons. Fluorine, which is in the same group, also has 7. Hydrogen has 1, and oxygen has 6. Okay. Why does that matter? So if I'm bonding a hydrogen to a hydrogen, right? And each hydrogen only has 1 valence electron, I only need 1 bond to pair those up. And so bromine and fluorine both have 7 valence electrons. So I can tell you they're not going to be the answer because they would follow the same pattern. But let's see why. When I put 7 valence electrons around fluorine, I see 1 unpaired. That is very like hydrogen, which has 1 unpaired. So it will just bond like this to another fluorine with just 1 bond because we have 1 unpaired electron. If we look at oxygen with 6 valence electrons, it has 2 unpaired. So when oxygen bonds to oxygen, it has to look like that. So there we go. Number 14, which molecule is symmetrical in both shape and distribution of charge? So this means we are looking for something non-polar. So the atoms are arranged equally around a central atom typically, and that means the charge is distributed evenly. This HCl, I've got Cl on this side and H on this side. That can't literally be even. Here I drew what water looked like. That is not an even distribution of charge. So now between these two, which one has an even distribution of charge and it is symmetrical in shape? It is methane. Okay, ammonia is polar. Number 15, what occurs when 2 atoms of bromine react to form a molecule? Now, you should understand, first of all, that means a bond is formed. So we can automatically get to a 50-50 here, right? Because we know that a bond is formed. Now, what you have to remember is this, that when you try to break something, you have to put energy in. That means energy is absorbed. So when you form a bond, energy is released, okay? Number 16, atoms of which element have the strongest attraction for electrons in a chemical bond? Well, I know this answer without looking up anything, just because I know kind of the fact about it, but let's look up electronegativity. So here's electronegativity, and what are we looking for? Fluorine, nitrogen. Okay, so electronegativity, fluorine, nitrogen, what else? Phosphorus and potassium. Okay, so we have phosphorus and potassium. So which one has the highest electronegativity? Yeah, it's fluorine. How do I remember it? Because literally the symbol for fluorine is F. That's like the worst grade you could get but it's the strongest electronegativity. Fluorine has the perfect electronegativity. All right, number 17. Heat flows from an object at a temperature of 20 degrees Celsius to an object at a temperature of, well, first of all, heat flows from warmer to colder. Also, I could figure this one out by doing the whole Sesame Street. One of these things is not like the others. Okay, 20 to 25 is going up in temperature. 20 to 35 is going up in temperature. 20 to 45 is going up in temperature. So the only way that the heat from 20 degrees Celsius can flow toward another object is if the temperature is initially lower. So it would have to be 15 degrees Celsius. Okay. Number 18. According to the kinetic molecular theory, an ideal gas has particles with large volume, no, tiny volume. Large atomic radii, no, tiny. No, oh yes, no attractive forces, no random motion. That is absolutely not true. They do have random straight line motion. Number 19. Which samplet STP contains the same number of atoms as 2.0 liters of HE gas at STP? So this is Avogadro's law. And Avogadro's law says that at the same temperature and pressure, which I know these are because they're both at STP, a sample of gas will have the same number of molecules if it has the same volume. So there is the same volume. Number 20, all chemical systems at equilibrium have equal, what do they have equal? They have equal rates and constant concentrations. So equal rates and constant concentrations. Number 21, which expression represents the heat of reaction for a chemical change? So if we're talking about a chemical change, how do we find the heat of reaction? That's delta H. So what we do is we do products minus reactants. Must be in that order. Products minus reactants. Number 22, which phase change represents an increase in entropy? Entropy is disorder, right? So when are things getting more disordered? Well, if we consider going solid, liquid, gas, as we move this way, we get more disordered. So that would be going from a liquid to a gas. All right. Number 23. Systems in nature tend to change toward. Well, what do they tend to change toward? First of all, the universe is like, please don't make me put forth more effort than I need to. So it loves low energy. So high energy is out. Now, because it loves low energy, it has to leave things in disorder because to put things in order takes energy. So they're linked together. So in order to have low energy, you have to have high disorder or high entropy. Okay. Number 24, which name represents a hydrocarbon? So we can get some reference table help for this one. If we go to table Q here, here is where we find hydrocarbons. And you can see that the names of hydrocarbons end like this, either ANE, ENE, or YNE. So when I look through these names, okay, well, this ends a known wrong. This ends a null wrong. Now this one ends with ane, but then it has this other part here. If you look again at these names, I just have a carbon prefix and then an ane, ene, or eine. So if I go here, you can see this iodo part is here. And these are not hydrocarbons. They are organic, but not hydrocarbons. So it's going to be number 1. Number 25. Which process occurs at the anode in an electrolytic cell? So it doesn't matter if it's an electrolytic or not. You can remember this, an, ox, red, hat. So at the anode, we have oxidation, always. Which formula represents an electrolyte? Well, what things are electrolytes? Acids, bases, and salts. Okay. What things are not electrolytes? So non-electrolytes. Okay. Typically, we'll look for something that is covalent or molecular. Okay. That's typically how we identify those. So if we look here, water is just covalent, right? Now, easy way to kind of help yourself a little bit is to go to the reference table and look at K and L, right? Because if I can identify an acid or a base, well, that helps me. And so if you notice this right here is one of the options. So that is an acid. So I can look for an acid, a base, or a salt. If I don't have one of those, then I'm going to want to eliminate my organic compounds, and then often that will lead me to the salt. Okay, but in this case, it was an acid. Which formula represents an Arrhenius acid? Again, I'm going to the same reference table, and it's the first one in the list. That's an easy one. 28. According to one acid-base theory, an acid is a substance that, okay, now first of all, does this acid-base theory, which by the way is the Bronsted-Lowry theory, does it deal with hydroxide ions or hydrogen ions? It deals with hydrogen, so I can cross out the hydroxide. So what do acids do? They donate, they give away H pluses, okay? Number 29, which nuclear emission has the greatest mass and ionizing power? Again, this is a reference table question, so let's look at table O. If you see the top numbers, the top number is mass, right? So the one that has the greatest mass and the greatest ability to ionize, meaning it smacks into something, can cause an electron to be lost, would be an alpha particle. There we go. Which statement describes a benefit? So that's a plus of the nuclear reaction that occurs in a nuclear power plant. Large amounts of water are needed to cool the reactor. Well, that doesn't sound like a positive. The power plant reaction can be used in dating geologic formations. That doesn't sound right. Radioactive isotopes are stored for a very long time at the power plant site. Well, storing radioactive stuff doesn't sound like a positive. Hopefully this last one works. A large amount of energy is produced from a small amount of a radioisotope. Remember, yes, nuclear reactions produce a huge amount of energy, more than any other kind. Okay? Okay, on to B1, the next 20 multiple choice questions. These ones tend to be a little bit more involved, okay? So here you can see we have a bright line spectra diagram, and then the question says, which elements are present in the mixture? So if it's present in the mixture, all of the lines have to be present. So here's a tip usually that helps. So anywhere where there's like a double line set, here, and here, what I'm going to do is look for those present in the mixture first. So if I look down, this band as well as this band are not present. So J is not in the mixture. But when I look down, these two bands are present in the mixture. So it looks like G, because that's all that G has, right? Now, if I look right here, see how L has this line, and I go down to the mixture, yeah, it's not there. So there's no L, okay? Which means if all of my options have two choices and it's not J and it's not L, then I know what the answer is, right? It has to be E and G. 32. Which particle diagram represents a noble gas at STP? So what do you need to know about noble gases? Well, they don't bond, right? Or they tend to be very unreactive because they have a stable set of valence electrons. So if you can look at this diagram, that shows stuff bonded. This shows stuff bonded. This shows stuff bonded. This is what we call diatomic elements, okay? And those elements are bring, cool, off. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Those are the diatomic elements. This over here is a compound. This is a different compound because it's a different ratio. Okay. This is an element, but it is a monatomic element, which that is what a noble gas is. So the correct answer here is number 2. Okay, number 33. A student determines the density of a copper sample at room temperature to be 9.46 grams per centimeter cubed. Based on table S, what is the student's percent error in determining the density of copper? Well, I guess I need table S, right? So here's my reference table. Let's go to table S, and I need to find copper. Here it is. Now, which column is density? It's this one over here. So this is the density of copper. So that is from the reference table. So 8.96. Now I need from the reference tables a formula from the back page, which is for percent error. So I have measured minus accepted. What is the accepted? Well, the accepted is just what I looked up. So 8.96. So 8.96 is on the bottom as well, right? I can't forget the times 100. But what is the measured value? Well, that was from the question. That's what the student did, 9.46. All right, so in my calculator, I need to do 9.46 minus 8.96, do equals, okay, divided by 8.96 equals times 100. All right, so I got this answer, 5.58. So let's look. What do we think our answer is? Well, the one that would round to 5 from 5.58 is 5.6, right? 5.58. That's an 8. That would round up to 5.6. What is the gram formula mass of MgNO3 2? So gram formula mass, I need the atomic mass of each thing. So I need to go back to the reference table. And let's look up magnesium. It's 24.305 or 24.3. Okay, so magnesium 24.3. All right, what about nitrogen is 14, oxygen is 16. So nitrogen is 14, oxygen is 16. So the magnesium was 24.3, and there's one of them. Perfect. Nitrogen is 14, but how many nitrogens are there? Well, one inside the parentheses, right? Times the 2 outside. So for nitrogen, there are 2 nitrogens. And oxygen was 16 times. How many oxygens are there? Well, it's 3 inside the parentheses times the 2 outside. So it's 6 oxygens, right? So that means it's 24.3, right? 14 times 2 is 28. 16 times 6 is 96. So now I need to add all of those numbers up, okay? So I need to add 24.3 plus 28 plus 96. And I get 148.3. So which one of those answers would that round to? Yeah, 148. Compared to a rubidium atom, a Rb plus ion has. So if it has a positive charge, right? What does that mean? Well, the only particles that can move are electrons, right? and electrons have a ding, ding, ding negative charge. So if rubidium has a positive charge as the ion, that means it lost an electron. Okay, so if the ion has one less electron, the atom actually lost the electron. Now the ion has less electrons, so the ion would be smaller, correct? So that should make sense, right? Now it's smaller, why? It's smaller because it has less electrons, all right? 36. Which ion in the ground state has the same electron configuration as an atom of neon in the ground state? What I'm going to do is look up the atomic numbers for each of these. So potassium for the atom has 19. Lithium for the atom has 3. These are the atomic numbers, so that's the number of protons and the number of electrons in the atom. Fluorine has 9. And chlorine has 17. Well, this is talking about the atom, right? So if potassium has a positive ion, it lost 1 electron. So it now has 18. Lithium with a positive charge has lost 1 electron. So it has 2. Fluorine with a negative charge has gained 1 electron. And chlorine with a negative charge has gained 1 electron. So let's go back to the periodic table and look down group 18, the noble gases. What else do we have to know the name of? Group 17 is the halogens. Group 2 is the alkaline earth metals. Group 1 is the alkali metals. And groups 3 through 12 are the transition metals. Okay, so if we look at these noble gases, you can see that, well, first, helium has 2 electrons, neon has 10 in the atoms, right? Argon has 18, krypton has 36, and so on. So my question was asking which one has the same electron configuration as neon? Well, neon has 10 electrons. So which ion ended up with 10 electrons? Yeah, fluorine. Which substance cannot be broken down by a chemical change? So this, we are looking for an element. Compounds can be broken down, elements cannot. Now, if you don't recognize the name of the element, what should you do? Go to table S and start scanning the names, okay? And one of them you will find on that list. And eventually, if you didn't know it already, you will find out that it is barium. Number 38, the difference in which property allows the separation of a sample of water and sand using a filter paper and a funnel. So here's a beaker, we've got a filter paper, we put sand and water, sand gets stuck on the filter paper and the water goes through. So what different properties do they have? Well, they have a difference in particle size. Particles that are too big get caught on the filter paper. Number 39, according to table F, which compound has a very low solubility in water? Well, first of all, it said table F, so please, come on now. I hope you know that you should turn to table F. So let's get there. Here we are, table F. Very low solubility. So if we look at the bottom right here, insoluble really means the ones that have very low solubility. So we're looking for something that is insoluble, okay? So we have sodium, sodium, and calcium, calcium. So let's look at table F. You could see this. If you don't remember, if you don't know that this is sodium, you're going to have to look that up on table S, find it here. But if you see that sodium is here with no exceptions, meaning sodium is always soluble. So these are both wrong, okay? Now, either calcium hydroxide or calcium phosphate is my answer. So I have phosphate and I have hydroxide here. I don't have calcium in any of the rules. So you can see that phosphate has exceptions, but it's group 1 and calcium is not in group 1. If you don't remember that, then you just look. Here's calcium in group 2, not in group 1, right? So let's go back to table F. And calcium is not this. So let's check hydroxide. Oh, look at this. Hydroxide, when it is with calcium, has an exception. That means it is no longer insoluble, it becomes soluble. So the only one that stays insoluble is calcium phosphate. All right. Number 40. What is the molarity of a NaOH solution containing 0.125 moles of NaOH in 0.200 liters of water? Okay, so let's go to the formulas. And we have one for molarity, moles divided by liters. So moles divided by liters, right? So let's open the calculator. Moles, 0.125, divided by liters, 0.2, is 0.625. And that is an answer. It's always a good sign when we do the math and we get the right answer. Number 41. Compared to a 0.10 molar aqueous NaNO3 solution at 1 atmosphere, a 1.0 aqueous NaNO3 solution at 1 atmosphere has, well, look, we have lower and higher, and we have boiling point and freezing point. So remember, here is thermometer. So 100 degrees Celsius is the boiling point of water. 0 degrees Celsius is the freezing point. When we add stuff, the boiling point goes up and the freezing point goes down. It goes up more when we add more stuff, and it goes down more when we add more stuff. So if we're comparing it to this one has more stuff. It has a bigger molarity. So it would have what? A lower freezing point and a higher boiling point. Number 42. What is the temperature in degrees Celsius of a sample of matter at 35 Kelvin? Well, that's a formula question right here. Okay, so K equals degrees Celsius plus 273, right? I know my Kelvin is 35 equals degrees Celsius plus 273. So I need to subtract 273 from both sides. So 35 minus 273 equals negative 238. Number 43. Which graph represents the relationship between pressure and volume for an ideal gas at a constant temperature? Well, the relationship between pressure and volume is that when pressure goes up, volume goes down, right? So if we have, this is low pressure but high volume, this would be high pressure but low volume. So it's got to be this one. That shows that inverse relationship. Number 44, which equation represents a physical change? That means I have the same exact stuff, the same exact chemical formulas on both sides. So yes, I have the same elements, but those chemical formulas are not the same. Yes, I have the same elements, but those chemical formulas are not the same. Here we go. Those chemical formulas are the same. The only thing that changed was the state of matter, and that makes it a physical change. Number 45. Which combination of reactants would result in the fastest reaction rate? Well, first I'm going to look, I can either have strip of zinc or powdered zinc. Which one reacts faster? Powdered, because it has a greater surface area. Now, the other thing I could have is a 2 molar or a 0.2 molar. Which one would react faster? The 2 molar, because the 0.2 has a lower concentration. So powdered zinc with the higher concentration would react the fastest. Number 46. Which equation represents a redox reaction? Well, the easiest way to look for a redox reaction is look for single elements on one side that are combined in a compound on the other side, like this, single element, but a formula on this side, that means oxidation numbers had to change. Okay? Number 47, which equation represents reduction? So remember we practiced this just drawing a quick little number line, 0, 1, -1. We put an arrow across this way, that represents Leo. We put an arrow going backward here, that represents Ger. The arrow points to the side of the equation, we need the electrons. So if it's reduction, that's Ger. Look way the arrow points toward the reactant side. Here, electrons in the wrong spot. Here, electrons in the wrong spot. Okay? Now I have to decide between these two which one is correct. So now I check for, does charge balance? 0, -1, +1. No, those two sides are not equal. What about this one? +1, -1, and 0. Yes, because +1 and -1 equals 0. So we had to have electrons on the correct side of the equation, and we had to have balance of charge. Okay. Number 48, the pH value of a solution is changed from 6.0 to 4.0. Which phrase describes the change in the hydronium ion concentration of the solution? Well, first you should know that pH is based on logarithms, and logarithms are based on 10. So it can only change by factors of 10, which means 10, 100, 1,000, and so on. So that means these are wrong, right? Now, the hydronium ion either increased or decreased. So here's pH from 0 to 14. At 14, we have the most hydroxide. At 0, we have the most hydrogen or hydronium, because remember, hydrogens just like to stick to water molecules. So I have more hydrogens the closer I am to 0. If I went from 6 to 4, do I have more H's or less H's? Well, I moved this way, closer to 0. That means I have more H's, right? Number 49. What type of cell is represented by the diagram and what change occurs? Well, first of all, bzzz, see this power source? That means it's electrolytic. So these are wrong. Now, what energy change happens? Well, think about this. The power source is providing electricity. So we start with electrical energy. Okay. And that electrical energy is what produces the chemical change. Okay. And then number 50, which equation represents nuclear fusion? So fusion is when you take two little nuclei and put them together and make a bigger one. So this started with one nuclei, wrong. All right, these two, which is too little making a bigger. That's this one. This would be fission. And these two would both be natural decay or natural transmutations. And that is the end of the multiple choice. On to B2. These are the easier short answer questions, and it's from 51 to 65. So 51 is a standalone question. All right. Determine the molecular formula for a compound that has the empirical formula CH2O and has a molar mass of 180 grams per mole. So first, what I want you to understand, if this is the empirical formula, that could be the molecular formula, but the molecular formula could also be something that's a multiple of it. So it could be everything times 2. So it could be, for example, C2H4O2. It could be everything times 3. So for example, C3H6O3. It could be a multiple of a 5. So C5H10O5. It could be a multiple of 10 and so on. What I need to do is figure out which one it is. So I'm going to take the CH2O and I'm going to find the molar mass or gram formula mass. So I need the periodic table, and the molar mass of carbon is 12, of oxygen is 16, and of hydrogen is 1. So carbon is 12, hydrogen is 1, but times 2, right? And oxygen is 16. So this is 12, 13, 14 plus 16 is 30 grams per mole. Now, if the molecular formula is the same as the empirical formula, this would be identical to the molar mass of the molecular formula, and it's not, right? So I have to figure out how it's different, right? So how is it different? Well, I could do this, 180 divided by 30. And that is 6. So in reality, the molecular formula is not 2 times bigger or 3 times bigger or 5 times bigger. It is 6 times bigger. So my answer would be C6H12O6. Numbers 52 through 54 go together. 52. State the trend in atomic radius for these 4 elements as they are considered in order of increasing atomic number. Those are my elements. Let's find them right here. Okay. And I need the trend in atomic radius as they're considered in order of atomic number, not the order they're written here, in order of atomic number. So let's look up fluorine, chlorine, and bromine. So I need to go to table S. Fluorine and atomic radius is the last one. So fluorine is here, chlorine is here, and then bromine is here. So what happens to the atomic radius? Okay. Well, my fingers are totally on the wrong keys. The atomic radius increases. 53. Determine the mass of a sample of iodine that has a volume of 2.5 centimeters cubed at room temperature and standard pressure. So I have volume and I want to find mass. So I have to figure out a way that I can use mass and volume, but what? So I'm going to take a second and look at the formulas. What formulas? Oh, there's one. It's the density formula that uses mass and volume. So density equals mass over volume. How would I find the density of iodine? Well, I would go here, right? To the reference table. Density is this one. Here is the density of iodine, 4.933. Right, so there we go. Equals, mass is what I'm trying to find, and there is the volume, 2.5. Put it over 1, cross multiply. 1 times mass is just mass, and I'm going to multiply those two numbers together to get my answer. So 4.933 times 2.5 equals 12.3325 grams. I could just leave it like that. I don't have to round a single darn thing. Okay. Now, if you're curious what the exam allows for your answer, it allows any answer, okay, from 12 grams to 12.333 grams. My answer is in between those, right? So that's beautiful. That's perfectly right. Any answer, though, in that range. Okay. So I could have rounded it to 12.3 or 12.33, right? Or 12.333. That would be the upper end. Or I could have rounded it to 12 at the lower end. I tend to discourage rounding to a whole number, so just be careful with that. I would typically, if you're going to round to a digit after the decimal, or just write what the calculator gives you. Okay. Number 54, state in terms of electrons. So my answer literally must say electrons. Why these elements have similar chemical properties. They have the same number of valence electrons. That is why they have similar chemical properties. Okay, so if you look at the periodic table, you can see that they all have 7 valence electrons. You cannot simply say that they are in the same group because that does not mention the word electrons. So please, when it says in terms of, say that word in your answer. Okay, 55. State the polarity of a CO2 molecule. This is one of those molecules you just have to know what it looks like. Looks like this. That's the Lewis dot structure. This is a polar bond, but look, this pulls this way, and then this pulls this way because oxygen has the higher electronegativity. So these two oxygen molecules are pulling in this like opposite directions. So the charge ends up being distributed equally. So the molecule is non-polar, even though the bonds are polar, but that's not what it asked, okay? Now, based on table S, determine the electronegativity difference between oxygen and calcium in calcium oxide. This is actually a super easy question. I just need to look up the electronegativity of oxygen and of calcium, right? And just subtract them. So I just do 3.4 minus 1.0, which is 2.4. Almost seemed too easy, right? Okay, 57 through 59. Classify in terms of saturation the type of solution produced. Okay, so what I need to do now is look up here for the solution. So I have this many grams of ammonium chloride in 100 grams of water at 25 degrees Celsius. Now, you need to know that that's a reference table question, and I need to go to table G. So when I go to table G, right, I need to be at what temperature? 25 degrees Celsius, so halfway in between here. That's where I need to be looking, right? And the substance I'm looking for is ammonium chloride, or NH4Cl, which is right here, right, this line, okay? And I need to decide where this point would be. So if I was at 20 grams and 25 degrees Celsius, I would be right here. At 25 degrees Celsius, I would be saturated right here. Where is this point compared to the line? Ding, 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 ding. It is underneath the line. So I call the solution unsaturated. Okay. State evidence from table I that indicates that this dissolving process is endothermic. Well, if you don't turn to table I, come on, what are you doing? All right, so here is the dissolving process right here. What is the evidence from table I? This delta H is positive, okay? So delta H, so let me just draw it because it gives me a hard time this way. Delta H is positive. You could even identify exactly what positive it is. So positive 14.78, 14.78 is the value of delta H, or triangle H, okay? and state in terms of particle distribution why this solution is classified as a homogeneous mixture. The particles are evenly distributed. That is homogeneous. So it is homogeneous when the particles are evenly distributed. So mixed uniformly, mixed evenly, something like that. 60 and 61, identify the interval during which the average distance between the particles is the greatest. So let's look. This is a heating curve, right? So we have solid. That's solid warming up. We have melting. So melting started, melting ended. We have a liquid heating up. We have boiling began, right? And so it's turning to a gas. Boiling ended, and now in this last section, the gas is heating up. So where are the particles the furthest apart? In EF. State what happens to the potential energy of the particles during the melting of the substance. Okay, well, during the melting right here, the kinetic energy is constant, but the potential energy increases. So remember, this is just following this pattern. Let's just change the color here. Kinetic increases. Oops, it didn't change the color. There we go. Kinetic increases, potential increases. Kinetic increases, potential increases. Kinetic increases. All right. Now 62 through 65. State the color of bromcresol green indicator if it were added to the sample of the 0.10 molar KOH. So let's go to the reference table for a minute. What I'm going to first look at, KOH is a what? Base. Bases have a pH greater than 7, right? So what color would bromcresol green be in that case? So let's look. Here's bromcresol green. Here's 7 compared to these numbers. Well, 7 is bigger than that number, so that means it will be this color, which is blue. State the number of significant figures used to express the concentration of KOH. Well, here is the concentration of KOH. Notice that there is a decimal point in that number. When there is a decimal point, we begin counting in this direction. That first number is a 0. Skip it. The second number is not a 0. Begin counting there and then count everything else. So we have 2 significant figures. Determine the concentration of the HCl aqueous sample using the titration data. So now we need a formula from the reference tables. We need this one right here. Remembering that the Ma is the molarity for the H plus and the Mb is the molarity for the OH negative. Okay, so let's just put it down here. So MaVa equals MbVb. Let's write my list of variables. MaVa MbVb. All right, so let's start reading. I'm just going to switch my color again. Okay. A 30 milliliter sample of this, well, that's the acid, and that's a volume. So that's 30.0 milliliters. 18 milliliters of, so 18.0 milliliters of 0.10 molar KOH. So let's look. HCl has how many H's? 1. Love it. KOH has how many OH's? 1. Love this. Okay. So Ma is my X, right? Times 30 equals 0.10 times 18.0. So this is 30x equals, what's 18 times 0.1? 1.8. Divide both sides by 30. All right, so 1.8 divided by 30 equals 0.06 mole. There is my answer. Okay. Number 65, compare the hydroxide ion concentration of the 0.1 molar KOH with the hydroxide ion concentration of the resulting neutral solution. Well, this we said, remember, was a base. So on the scale, on the pH scale where 7 is neutral, KOH is over here between 7 and 14, right? Now it says the resulting solution is neutral. When it is neutral, we have H pluses equal to OH negatives, but that's not what it's asking us, okay? I want to know how the hydroxide ion concentration compares. So that means the neutral solution has less hydroxide ions, right? The 0.10 molar KOH has more hydroxide ions. You don't have to say both, you just got to say one of them, okay? And that is the end of B2. One section left. All right, time for part C, the last short answer questions. So 66 through 68. Compare. Whoop, whoop, love a compare question, right? So compare the number of protons to the number of electrons in an atom of oxygen 18. Well, I don't quite frankly care. It's an atom of what? If it is an atom, it is neutral, right? And since protons are positive and electrons are negative, the number of protons and electrons must be equal. So the number of protons and electrons must be equal in atoms. That's just the rule. 67. In the space in your answer booklet, draw a Lewis dot diagram for an atom of oxygen. So just as a reminder for 67, this is what it's going to look, a big space. So oxygen, if you don't remember, let's look it up on the periodic table, has 6 valence electrons. That is what I need to show on the Lewis dot diagram, right? So I can do it here. All right, so an electron dot diagram for an atom of oxygen. Here is oxygen. I need 6 valence electrons. 1, 2, 3, 4, 5, 6. Ta-da, like that. 68. State in terms of neutrons. So I literally got to say the word neutrons. Why a water molecule containing an O18 atom has a greater mass than a water molecule containing an O16 atom. So if we have O18 and O16, right? If we look it up on the periodic table, oxygen's atomic number is 8. So I don't care if it's oxygen 18 or oxygen 16, it has 8 protons. So when I subtract these, that tells me the number of neutrons. So why a molecule that has oxygen 18 would have a greater mass? Because oxygen 18 has more neutrons. So oxygen 18 has more neutrons. I could say it has 2 more neutrons, but I don't have to. I just have to say it has more. Or oxygen 16 has less neutrons, so it would have less mass. Okay. And then we have 69 through 71. Show a numerical setup for calculating the percent composition by mass of oxygen in the sodium hydroxide carbonate. And it tells me the gram formula mass. So from the reference tables, right, I need percent composition by mass. So here we are for question 69. So for percent composition by mass, I have mass of part over mass of whole times 100. So I have mass of part over mass of whole times 100. Now, I was given the gram formula mass, and the gram formula mass is the whole. So now I know that the whole is 84, right? I need the part, okay? And I got to keep the times 100. So it was asking me to find the percent composition by mass of oxygen in this, right? So here is the formula for sodium hydrogen carbonate, right? How many oxygens are in that formula? 3. What is the atomic mass? The molar mass of each oxygen? Each mole of oxygen, 16. So the total mass for the oxygen piece is 3 times 16. So 3 times 16. Now I can be done. That's it. I can leave it just like this because it just asked me to show a numerical setup. I can be done. Ta-da! Don't do any of the math because if you make a mistake, potentially you could lose points. That's it. I could leave it as 48 over 84 times 100, but I don't have to. This is good enough. This is also correct. Okay. And number 70, determine the number of moles of K2CO3 produced when 3.5 moles of KO2 completely reacts as represented in the equation. Okay, so I have 3.5 moles of KO2, and I want to know how many moles of K2CO3, right? So I'm gonna, find the equation, and it says equation 1, so I gotta look here. What is the coefficient in front of KO2? 4. What is the coefficient in front of K2CO3? 2. So now I just cross multiply, right? 3.5 times 2 is 7. This is what I'm trying to find, 4 times x, right? Then I'm going to divide by 4. So what is 7 divided by 4? 1.75 volts. Okay, now 71 is balance in an equation. So here's my equation, which looks complicated, right? So let's just make a list of elements. We have Na, H, C, and O. So Na, H, C, and O. There's my divider, right? So over here I have 1, 1, 1, 3. On this side I have 2, 1, 3, 2, another 1. Here I have another 1, and then 2. Oh my goodness gracious. So this is 2 total carbons, right? And this is 6 total oxygens. Oh, good gracious. This is a hot mess, right? Okay. What I'm going to try to do is, I don't even know. Okay. I'm going to put a 2 in front of this because why? I have 2 NAs here and 2 H's and I only have 1. So I'm going to try it. Let's see what happens. Let's put a 2 there. When I put the 2 there, I multiply this times 2. It also multiplies this times 2. It also multiplies this times 2. And it also multiplies, oh my goodness gracious, look at that amazingness. Everything else is balanced. Ugh, who knew? Now I can leave everything blank. Or if blank stress you out, 1, 1, 1. Or leave them blank. Totally fine. All right, question number 72 and 73. 72, determine the volume of this sample of helium gas at 350 Kelvin. So that's this point, go across, it's right here. So what do I put? It's maybe, this would be 5.5. This is 6. So like 5.8 liters. Fun fact, what they accepted on the answer key, right, is anywhere from 5.6, so it definitely was not on the line for 5.5, right, to 5.9. And it was definitely not on the line for 6. So this they gave amazing grace for what the answer could be. Number 73. Compare, beautiful, love it, right? Either equal or greater. Compare the average kinetic energy of the helium atoms in the sample at 200 K to the average kinetic energy of the helium atoms at 300 K. I literally love this. What is average kinetic energy? Temperature. So look at this temperature. Look at this temperature. Okay. So the average kinetic energy is greater in the 300K sample, right? Because it has a higher temperature. That's it. That's all I got to say. I mean, you could word it a different way. Say the average kinetic energy is less in the 200K sample. There's more kinetic energy in the 300K sample, right? There are lots of ways to word it, but that's really the answer. Okay. All right, 74 through 77. We're getting so close to the end. Here we go. Explain in terms of, okay, so collision theory. So that means I got to talk about colliding, right? So explain in terms of collision theory why reacting hydrogen and nitrogen at high temperature increases the rate of the reaction. So the answer, whenever rate of reaction increases, the rate of reaction increases because there are more effective collisions. Now, I could just say more collisions, right? But more effective collisions is like the truer, right? But the rate increases because there are more collisions. How do you increase rate? Increase collisions. How do you decrease rate? Decrease collisions. All right. Determine the net quantity of heat released when 1 mole of ammonia gas is produced by this reaction. So if I look up here, I don't see anything about a number except for here. Aha. Okay. So it says when 1 mole of NH3 is produced. So I have this number of kilojoules released, right? But look how many moles of NH3 were produced. So how would I determine how much energy was released when I had 1 mole? Well, it literally would be half that, right? So I would just do 91.8 divided by 2. Why? Because 91.8 for 2 moles, but I only have 1 mole. So 91.8 divided by 2 is 45.9 kilojoules. So 45.9 kilojoules. Number 76. Using the axes in your answer booklet, draw a potential energy diagram for the reaction. Okay, so before I even go there, let's think about what I need to draw. This is the energy, right? And it is on the product side, which means it is exothermic. Energy is coming out. If energy is coming in, it's endothermic. If it's going out, it's exothermic. So let's go to the diagram. Okay. All I need to do is draw a potential energy diagram that starts with the reactants, goes up until I reach the activated complex, and then I need it to be exothermic. So I need it to come down like that. And that's it. It was that simple. And 77, state again in terms of activation energy and reaction pathway. 2 things I got to say in my answer. Why the addition of a catalyst increases the rate of the production of ammonia. So a catalyst, it's basically the definition of a catalyst, provides an alternate, right? An alternate reaction pathway with a lower activation energy. That's literally the definition of a catalyst. Okay. Getting closer, 78 through 81. Identify 78. Identify the element present in the reactants that allows them to be classified as organic compounds. Literally carbon. Bam. Okay. Write a chemical name for reactant 1. So here's reactant 1. Where do I find help with naming this? I got to go to table. So go to table R. And now if you see, I'm looking for something that ends with COOH. So this just ends with OH. No, this is COH. Aha, look at this. COOH. Okay. So that's an anoic acid. So the name is going to be something anoic acid. What do I have to put in front? Well, let's look at the reference table. This is prop because I have 1, 2, 3 carbons. So how many carbons are in this reactant? 1, 2. What is the prefix for 2 carbons? F. So if I go back here, the name of this would be ethanoic acid. Number 80, write a formula for the missing product X in the equation. So I got to figure out what's missing, right? So here are where the two sides of the equation are, all right? Let's start with this. Let's count carbons. 1, 2, 3, 4, right? How many on this side? 1, 2, 3, 4. Oh, okay, so I'm not missing any carbons. All right, let's pick a different color. Let's pick this light purple. Hydrogens, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. And then I was like, what is happening? But this, I missed this. So I'm missing 2 H's. So I'll go through that again. So that's 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens on this side. But this side I have 3, 4, 5, 6, 7, 8. So see, I'm missing 2 hydrogens. All right, now let's pick another color for oxygen. 1, 2, 3. On this side, I have 1, 2. So I'm missing 1 oxygen. So what would the formula be for the thing that's missing? H2O or HOH. 2 hydrogens and 1 oxygen. All right, and 81. Identify the class of organic compounds to which this belongs. All right, that is table R. So what am I looking for? I'm looking for some carbons over here, some carbons over here, right? And in the middle, I've got 2 oxygens. So here, this is the only one that has 2. See, this has 2 oxygens, but it's got a hydrogen on this end, and I need carbons. So 2 oxygens in the middle with carbons on either side. That class of compound is an ester. Okay. And our last section, 82. Compare, love a compare, right? Compare the penetrating power of the beta particle emitted from the iodine 131 nuclide to the penetrating power of the alpha particle. Well, the penetrating power of the beta particle is greater. Okay, why? We'll just look at table O for a minute. Here you can see alpha particles have a mass of 4, whereas beta particles have a mass of 0. So beta particles are able to penetrate through more things. They get blocked by less. Okay. Number 83, complete the nuclear equation in your answer booklet. So let's go to the answer booklet right here. Here, for our purposes, that's where the equation is divided. So on this side, I have 59. On this side, I have 0 so far. So my top number has to be 59. And the bottom, I have 26 on this side. And that has to be equal to -1 plus whatever my mystery number is. So I have to add 1 to both sides. So it should be 27. So I have 2 numbers, but now I need a symbol. So I need to go to the periodic table, and that is cobalt. Okay, that is the correct symbol. Be careful writing a capital C and a lowercase o. Number 84, determine the fraction of the original sample of the radioactive isotope used to test for thyroid problems that remains unchanged after 24.063 days. Well, I didn't even have to remember it. Look, it says that's the one that's used for thyroid, right? And determine the fraction. So let's just go through. First, if in a fraction, I start with 1, the whole thing. Then I would have a half. After another half-life, I'd have half of a half, which is a quarter. After another half-life, I would have a half of a fourth, which is an eighth. After another half-life, I would have half of an eighth, which is a 16th. But I need some reference table information. So from table N, iodine 131 has a half-life of 8.021 days. So that means this took 8.021 days, right? But I need it to go for 24 days. So this also took 8.021 days, which that's about 16. And this took another 8.021 days. Aha! That's enough. So 8.021 times 3, right, is going to give me this. So that means this half-life happened, this half-life happened, and this half-life happened. So what fraction remains? 1/8. And then our last question, finally, determine the number of neutrons in an atom of Am 241. So remember, the 241 goes at the top, but I need the atomic number because I can't do that without the atomic number. So I need to find it. Here it is way down here. There is its atomic number. It is 95. So if this is the mass number on the top, 241, which is protons plus neutrons, and this is protons, I subtract those numbers. So 241 minus 95 equals 146. That is how many neutrons I have. And there we go. Phew! We made it through the whole exam. Congratulations.